All right, in this lesson, we're going to learn about the reciprocal trig functions. We already know about sine, cosine, and tangent. We're actually going to learn 3 new functions today, okay? And they're abbreviated here, but I want to write them out for you. And you've heard this word before in geometry, but you've heard secant before, right? The word secant in the geometry, a little different meaning in trig, but secant, I'm going to write it out for you, secant is a new function we're going to learn today. And then there's the cosecant. And we're going to learn about the cotangent. So, we have 6 total trig functions. That's it. I won't add it. We won't be adding any more. There are 6 total trig functions. Sine, cosine. Tangent, cotangent. Secant, cosecant. 3 of them we already know. 3 of them are new today. Why do we learn them first, sine, cosine, tangent, then we learn cotangent, secant, cosecant? Why do we learn them like that? It turns out that the 3 new ones we're going to do today are the reciprocals of the 3 you already know. And here's the linkage. So sine gets linked to CSC. Now, cosecant is abbreviated CSC right down here. This is cosecant. That is a reciprocal of sine. That's confusing because a lot of students think, oh, the S goes with the S and the C goes with the C. That's not how it is. The cosecant is a reciprocal of sine. So if sine is opposite over hypotenuse, see how we linked it here? The cosecant is hypotenuse over opposite. That's just definition. You can't ask why, it just is. Okay, it's a definition. Cosine and secant are reciprocals. Cosine and secant, this has to be memorized. So see how cosine's adjacent over hypotenuse? The secant's hypotenuse over adjacent. And then tangent and cotangent are reciprocals. Opposite over adjacent. Cotangent is adjacent over opposite. That one's the easy one. That's one these students easily remember. So if you have a tangent and you flip it, you get the cotangent. If you have a sine and you flip it, you get the cosecant. If you have a cosine ratio and you flip it, you get a secant ratio of the exact same angle. And we're going to be doing this. Now, as far as the positive versus negative in the quadrant, that's what we're going to talk about here. Think about a number and you take the reciprocal. So like for example here, what is the reciprocal of 4? The reciprocal of 4 is 1 over 4. That's a 1/4. The reciprocal of 2/3 is 3 over 2. So if you knew if the sine was 2/3, you would know that the cosecant was 3 over 2. You simply are going to just be flipping them. So that's very, very easy in concept. You just got to memorize it, all right? What about -5? The reciprocal of -5 is -1 over 5, and the reciprocal of -3/4 is -4/3. Why did I have you do all these to practice? Because I want you to notice that when you started with a positive and you take a reciprocal, you still have a positive. You started with a positive, you flip it, you still have a positive. When we started with a -5, we flipped it, we still got a negative. We started with a -3/4, we flipped it, we still got a negative. Flipping or doing the reciprocal does not change the sign. It just flips it. It just takes the numerator, makes it the denominator becomes the numerator, but the sign does not change. And that's what's nice about this. And that's how we're going to come up with the positive and negative in the quadrant. Now remember we did ASTC, all positive, sine positive, tangent positive, cosine positive. That's where these functions are positive. They're negative in the other quadrants. Well, if we're going to do one of these now for sine, for the new functions, okay? So everything's positive in quadrant 1. If you flip a positive, you get a positive. In quadrant 2, if the sine is positive, then its reciprocal must be positive. The reciprocal of sine is cosecant. So the cosecant must be positive in quadrant 2. In quadrant 3, the tangent was positive, so the cotangent is going to be positive. Only the reciprocals are going to be positive. In quadrant 4, the cosine's positive, so the reciprocal, which is the secant, cosine and secant are reciprocals. those are going to be positive, and that's it. So here's our chart, and again, it just follows the ASTC, and you keep the reciprocals. So here's an example. If cosine is positive 3/4, okay, the secant must be what? Well, the secant is simply the reciprocal. The secant of theta would equal 4/3. That's it, okay? If the cotangent is -3, what's the tangent? Well, the tangent is simply going to be the reciprocal. So if the cotangent's -3/1, you flip that, because -3 is -3/1, you flip that and you get -1/3. Mr. Ventry, why is this so easy? Well, it is, but you still got there's things you have to memorize. Okay, when we're in the middle, when you're going into a quiz or an exam, you have to memorize that the sine and the cosecant are reciprocals. All right, so let's move on here. We do some more examples. If angle B is in standard position and the secant is less than 0 and the tangent is greater than 0, in which quadrant would it be in? Now let's think about this here. So let's do secant less than 0. Secant negative. Now the secant's going to follow the cosine. It's going to follow the cosine because that's the reciprocal of cosine. So where's cosine negative? Cosine is negative in quadrants 2 and 3. Cosine's positive in quadrants 1 and 4, so it must be negative in 2 and 3. How about tangent? Let's do another one. Let's do another one for tangent positive. Where is tangent positive? Tangent's positive in quadrant 1. Because everything's positive there, and tangent's positive in quadrant 3. So, which one of these qualifies for both? Well, quadrant 3 is the one that got an x both times, so we must be talking about a quadrant 3 angle. So the answer to this question is quadrant 3. This one here, if cosine is 0, find all possible values of cosecant. All right, well, if cosine is 0, we're talking about an x value of 0. Remember xy? Okay, this is the cosine and this is the sine. If the cosine is 0, we're talking about this guy or this guy. So we must either be at 90 or 270. We got to be either 90 or 270 if the cosine is 0. Find all possible values of cosecant theta. Well, the cosecant is the reciprocal of sine. So it's 1 over the sine. So we're going to flip the sine. So at these points, the sine is the y value, and of course it's 1 or -1. So it's going to be 1 or -1. If you reciprocal 1, if you do the reciprocal of 1, it's still 1. If you do the reciprocal of -1, it's still -1. Okay, so the answer would be 1 or -1. If the cosine is 0, the cosecant will either be 1 or -1. What about if the cotangent is undefined? If the cotangent is undefined, that means the tangent must be 0 over 1. How do I know that? Because undefined is 1 over 0. Undefined is 1 over 0. You can't divide by 0. The tangent is the reciprocal of that. That would be 0 over 1. All right, so we're talking about 0 over 1. So where is the tangent 0 over 1? Well, the tangent, remember, tangent is sine over cosine. So where is the sine 0 and the cosine 1? The sine is 0 and the cosine is 1. I mean, the cosine is 1 and the sine is 0 right here. And that's going to be at 0 degrees, or 360. That's the only place where the cosine is 1 and the sine is 0. These are tricky. They're going to take some practice and probably some more explanations in class. The terminal side of theta in standard position intersects the unit circle at -1/2 radical 3 over 2. We learned the unit circle in our last lesson. This is the cosine and this is the sine. So that's what's nice about the unit circle is the point on the unit circle gives you the cosine and it gives you the sine. So these are easy if you have a unit circle. We already know the sine. The sine of theta, we don't even have to draw a picture. The sine of theta is going to be right here, radical 3 over 2. The cosine of theta is going to be right here, -1/2. Okay, so we already got that one and that one. Now the tangent of theta is sine over cosine. So it's going to be this one divided by this one. So it's just going to be negative radical 3 over 1. Right? So that's just negative radical 3. The cotangent is the reciprocal of that. So we're going to flip negative 1 over 3. It's going to become negative 1 over radical 3. And then we rationalize that. And that's going to be negative radical 3 over 3. And then the secant and the cosecant, let me clear this out for room. Now this is where we got to do a little bit of work here. The secant is the reciprocal of the cosine. You flip that, so you just do negative 2 over 1. That's easy. So the secant's just negative 2. And the cosecant is the flip of the sine. So we flip radical 3 over 2, we get 2 over radical 3. Now we're going to rationalize the denominator. We can't leave 2 over radical 3, so we get 2 radical 3 over 3. So my cosecant is going to be 2 radical 3 over 3. That's that. And the last example here, and I'll let you go, is when we do not have a unit circle. So we don't know the radius. So we have to draw this out. And that's going to be done the same way as soon as we're going to have to find the radius here. Negative 4, 8. All right, so we have some circle. Negative 4, 8 is in quadrant 2. Negative 4, 8, I don't know where that is. Somewhere in quadrant 2. So we were talking about right there. That's the point, negative 4, 8. So I'm going to draw a reference triangle. There's a right triangle. So this is negative 4, and this is 8. Remember, negative 4, the x value, it's left 4, and then 8 means go up 8. If I go left 4 and up 8, I get a reference triangle where I got to find my hypotenuse. It's not. This is not cosine and sine if we don't know the radius of the circle. So I got to find this right here. I got to find that hypotenuse. So I'm going to use my Pythagorean Theorem. 8 squared plus negative 4 squared is c squared. 64 plus 16 equals c squared, and that's going to be 80. So the square root of 80 is going to be my hypotenuse, square root of 80. So I'm going to just get rid of this and clean this up. So I'm in the second quadrant. I have a right triangle. I know this is negative 4. I know this is 8. And I know this is the square root of 80. And now I can do all my ratios. Okay? My sine is going to be opposite over hypotenuse. Here's my angle at the origin right here. There's my reference angle. I always go off of that. My opposite over my hypotenuse is 8 over radical 80. Okay, and then radical 80 simplifies. We're just going to write 8 over radical 80 for now. We would not leave that as a final answer. We would rationalize it. I'm just trying to save you time in the video here. So we're going to leave it on the video. In class, you'll have to rationalize that denominator. We cannot leave radical 80. Cosine is going to be negative 4 over radical 80. Okay. The tangent is going to be opposite over adjacent, so it's 8 over negative 4, and that's negative 2. All right. The cotangent is going to be the reciprocal of negative 2, which is negative 1/2. The secant is going to be the reciprocal of the cosine, so negative radical 80 over 4. And then the cosecant, hopefully you're fitting it in better than I am, the cosecant's the reciprocal of sine, which is radical 80 over 8. And again, you would have to simplify the radical. You can't leave radical 80, so you have to break down the radical and simplify that. I don't want to do that here and waste time for you. I just want you to practice getting the sine, cosine, and tangent, and then flipping. Flip, flip, flip. You get the 3 reciprocal functions. Okay, we will practice this in class. See you then.